नमस्कार दोस्तों, मैं शिवानंद उपाध्याय आपका स्वागत करता हूं हमारे YouTube चैनल केमिस्ट्री एकेडमी फॉर IIT JEE एंड नीट। यह जेई मेंस रिवीजन का दूसरा दिन है और आज हम मोल कॉन्सेप्ट के बारे में डिस्कस करेंगे और उसके बाद रेडॉक्स के बारे में डिस्कस करेंगे। मोल कॉन्सेप्ट का हमने एक अलग वीडियो बनाया और रेडॉक्स का अलग वीडियो बनाया, और वीडियो बनाते वक्त ये हमने ध्यान रखा है कि क्या जेई मेंस के लिए जरूरी है उन्हीं कॉन्सेप्ट्स को डिस्कस करें। बहुत सारे इंटरेस्टिंग कॉन्सेप्ट्स हैं, बट आवर फोकस इज टू स्कोर मैक्सिमम मार्क्स इन जेई मेंस। सबसे पहले हम सिग्निफिकेंट फिगर से शुरू करते हैं। ये बहुत सिंपल है, लेकिन मोस्ट ऑफ द स्टूडेंट एंड टीचर्स अवॉइड दिस, बट दिस इज वेरी इंपॉर्टेंट अकॉर्डिंग टू जेई मेंस एंड एडवांस। सो आई विल डिस्कस ऑल द पॉइंट्स रिगार्डिंग इट। तो सबसे पहला पॉइंट, फर्स्ट पॉइंट रिगार्डिंग सिग्निफिकेंट फिगर इज अबाउट एडिशन एंड सब्सट्रैक्शन। सो व्हेन वी आर डिस्कसिंग एडिशन एंड सब्सट्रैक्शन, suppose these are the numbers we want to add: 12.11, 18.0, 1.012. So in first we add these number, we'll get whatever the exact value it is coming, and then we have to answer, right? So while answering it, we will not count the number of significant figures. We will count the number of digit after the decimal place. Like in the first number, there are 2 digits after the decimal place. In the second number, there is 1 digit after the decimal place. And in the third number, there are 3 digits after the decimal place. So the least number of digit after decimal place is 1, that is in 18.0. So that's why while writing the answer, we'll write the answer अप टू 1 डिजिट आफ्टर द डेसिमल प्लेस, इसलिए इसका आंसर जो है वो 31.1 है। सो बी केयरफुल, वी आर नॉट काउंटिंग द नंबर ऑफ सिग्निफिकेंट फिगर्स in addition and subtraction. We are counting the number of digit after decimal place. So the number having least number of digit, the answer should have that number of digit. So this is about addition and subtraction. For multiplication and division, yes, we count the number of which has least number of significant figures. So the answer has the same number of significant figures. For example, if I am multiplying 2.5 with 1.25, in 2.5 the significant figures are, or digits are 2, and in this the number of significant figures are 3. So the answer is this 3.125, but the answer has 2 significant figures, so it is 3.1. So this is an example given in NCERT, how many significant figures should be present in the answer of the following calculation. So this is related to multiplication and division. In case of multiplication and division, we'll count the number of significant figures in different numbers. Like in the first number, the number of significant figures is 4. In the second number, the number of significant figures is 5. In the third number, number of significant figures is 3. In the fourth number, number of significant figures is 4. So this is the exact calculation, and if I have to answer, I have to answer with least significant figures. So answer have the 3 significant figure. So the final answer should have 3 significant figure. This is for multiplication and division. Same way, when we are discussing the second example here, 5 into 5.364. So if this 5 is a number, if it is an exact number, it has infinite number of significant figure. So assuming that this is a number having infinite number of significant figures, the second has 4 significant figures. So the answer should have 4 significant figures. The third example is for addition, and for addition and subtraction, we have discussed that we don't have to count significant figures. We have to count the number of digit after the decimal place. So the number of digit in the first is 4. In the second also the number of digit is 4, and in the third also the number of digit after decimal place is 4. So first we add them. On adding, we are getting this, and it has also 4 digit after decimal place. So the final answer has 4 digit after decimal place. And if we count the number of significant figure, the number of significant figure is also 4. So while counting the number of objects, like if I'm saying that 2 bananas, right, the number of significant figures is equal to infinite. But if I'm saying that this is 100 kg, if I'm measuring mass, or if I'm measuring length, if I'm saying that this is 100 kg and I have not mentioned any decimal place, so in 100 kg there is only 1 significant figure, only 1 significant figure. If this 100 is a number, definitely it has infinite number of significant figure. So if I writing this 100 kg in this form, 100 and then dot. So this dot is implying that we have to count these zeros also after. So the number of significant figures in this is equal to 3. And if I'm writing like this, so we know that 0 after the decimal point will also count in significant figures. So in this case, the number of significant figures is equal to 4. So when we are measuring some substance, it has some unit in kg, centimeter and all that. And if it is not represented, some decimal place is not there, so we'll only count the non-zero digits. So in 100 kg, 1 is only the significant figure. Okay. Same way, if we are counting for a significant figure in following examples, 0.25 ml. So this 0 is not significant. So after decimal, there are no two non-zero digits. So these are significant, two significant figures in 2.005. These 20 between two non-zero numbers are significant. So number of significant figures is equal to 4. In this 0.025, this 0 before non-zero digits is not significant. So the number of significant figures in 0.025 is equal to 2. So these are very simple things, but this is very important for mains as well as advanced. So please revise this. So there are 3 rules when we are rounding off, right? If we have done addition and if we want to write the final answer. So if the last digit, if the rightmost digit to be removed, if we want to remove the rightmost digit, and if that is greater than 5, then the preceding number is increased by 1. Like for in this example, 1.386, I have to delete this 6. So preceding number is 8. Since 6 is greater than 5, I will add 1 to this 8. So the final answer is 1.39. The second point is, if the rightmost digit to be removed is less than 5, the preceding number is not changed. For example, 4.3344, we have to delete or remove, and the preceding number is 3. 4 is less than 5, so will not do any change in 3. So it will remain 4.33. And the last and important point is, if the rightmost digit to be removed is 5, then there are 2 points. If the preceding number is even, then there is no change in preceding number. If it is even, there is no change. If it is odd, then it is increased by 1. It is increased by 1. We can see here in an example, we want to delete 5. It is 5, right? So the preceding number before 5 is 2. 2 is an even number, so there is no change. So the final answer will be 6.2. If we want to delete 5 in the second example, 6.15, but before that 1 is an odd number, so we'll add 1 to this. So the final answer will be 6.2. So these are the rules to round off, and they are very simple but very important. Now I have gone through the questions, past JEE mains question, and they are asking some basic definitions like relative atomic mass. There is a question in 2006 based on this. So when we are calculating relative atomic mass, it is mass of one atom of an isotopic element. Like if I am saying that nitrogen or carbon is there, right, or some element is there which has many isotopes. So I am discussing about atomic mass of a particular isotope. So that's why mass of one atom of isotopic element divided by 1/12 into mass of one atom of carbon-12 isotope. So this denominator is the reference. We can change the reference because initially we are using oxygen to calculate the relative atomic mass. Now today we are using this carbon-12 isotope by using 1/12. So this is relative atomic mass. If I change this reference, if I change the reference, the relative denominator, if I change, the relative atomic mass is going to change. So relative atomic mass depends on the reference. If you change the reference, the relative atomic mass is going to change. So let me read here that if we change the reference, then relative atomic mass will change. Mass of 1 mole of atom. So 1 mole is representing Avogadro number of chemical species. So mass of 1 mole of atom means mass of Avogadro number of atoms. So mass of 1 mole of atoms is not going to depend on this reference point. So mass of 1 mole of atom will not change on changing the reference point. For example, in JEE 2006, they have asked a question. If we consider 1 by 6 in place of 1 by 12, mass of carbon atom is taken to be the relative atomic mass unit, then the mass of 1 mole of the substance. If they are asking that what is the effect on relative atomic mass, so in relative atomic mass, in place of 1 by 12, if we are using 1 by 6, so definitely relative atomic mass will become double. But they are not asking about relative atomic mass. They are asking about what will happen to the mass of 1 mole of atom. So mass of one atom is not going to change, right? Relative atomic mass will change, but mass of one atom is not going to change, and Avogadro number is not going to change. So there is no change in mass of 1 mole of atom. So most of the student has written that atomic mass will become double, but that is wrong, right? Relative atomic mass will be double, that is correct, but mass of 1 mole of atoms is not going to change on changing this reference point, right? So I hope that you understand my point. So this is a question, a good question of JEE Mains 2006. Let us move forward. Limiting reagent. I was going through the questions and I found that so many times they are asking question based on basic information of a chemical reaction. So let me discuss this point, taking an example of limiting reagent. Find the moles of ammonia produced by mixing 5 moles of nitrogen and 10 moles of hydrogen. Whenever they are asking any information about chemical reaction, our first thing is we should write the reaction and balance it. And by balancing this reaction, what we are representing, like here I am balancing this 1 mole of nitrogen gas react with 3 moles of hydrogen gas to form 2 moles of ammonia. So suppose if I want to carry out this reaction one time, so I need 1 mole of nitrogen and 3 mole of hydrogen. If I want to carry out this reaction 2 times, I need 2 mole of nitrogen and 6 mole of hydrogen. So initially in this question, at time t is equal to 0, the number of moles are given. The number of moles of nitrogen is 5 and the number of moles of hydrogen is 10. So in order to carry out this reaction with 5 moles, so what we are doing, that we are dividing 5 with the stoichiometric coefficient of this nitrogen. Nitrogen stoichiometric coefficient in balanced reaction is 1. Dividing 5 by 1 means with the help of 5 moles, we can carry out this reaction 5 times. Same way, whatever the moles of hydrogen is given, if we divide it by its stoichiometric coefficient, it means that we can carry out this reaction 10 by 3 times. So obviously this 10 by 3 is a smaller number with respect to 5. So we are saying that hydrogen is going to completely consumed and nitrogen is left in the reaction. So when we are discussing that how to calculate, that is the purpose. So given moles divided by stoichiometric coefficient will give you that how many times that reaction can be carried out. So in this way, we have find out that hydrogen is the limiting reagent. Now we are writing that any time t moles, we are writing initial moles are 5. According to balanced reaction, if 1 mole of this is reacting, then 3 mole. So if x moles are reacting, then 3x moles are reacting. So this is the number of moles left. So we know that in this reaction, since hydrogen is limiting reagent, there is no moles of hydrogen will left. So from there we'll get the value of x. Value of x will be 10 by 3. So now if we put here and here, we will get that what is the amount of reactant left and what is the amount of product formed. So writing in this way will give the information about all chemical species. I hope that this is you already know, but this is very important because they are asking question based on this. Many times they have asked in JEE Mains. Okay, moving forward. Relation between molarity and density of solution. Again, it's a very simple topic, right? But we do some mistakes, like we forget the definition of molality, small m. Molality is number of moles of solute upon mass of the solvent in kg. You see, it is not the mass of the solution. And these type of questions are important for JEE Advanced also, right? Many times they have asked numerical value question based on this concentration terms. So we do not have to mug up anything, right? We should know some basics. So there is an example. Let me read out this and we'll give an idea that how to solve these questions without mugging up the relations, right? Some students try to mug up the relation between molarity and density. No need to mug up, right? You just remember the definition and approach logically. And these questions are very common. So I'm reading the question. Density of 2.05 capital M means molarity solution of acetic acid in water is 1.02 gram per ml. The molality of solution is, they are asking about molality, they have given molarity and density. So all concentration terms, all concentration like density, mole fraction, molarity, all concentration terms are intensive variable. Intensive variable does not depend on the amount of the substance. So whenever we have to calculate any concentration term, we should not afraid that what amount we should take. We can take any amount, but while solving we take some logical which will help in solving the question. Like here, molarity they have given. So I am taking, while solving this question, I am taking 1 liter of the solution. I can take 2 liter also. I can take 1 kg of the solution also. The answer is not going to change, right? So for my ease, I am taking 1 liter. From there, molarity into volume in liter, I have calculated what is the number of moles of acetic acid. Once I know the number of moles multiplied by molar mass of acetic acid, I am getting that 123 gram of acetic acid is there in this solution. And mass of the solution, because density and we have taken 1000 ml, 1 liter. So we know that this is the mass of the solution, 1020. Mass of the solution minus mass of the solid is equal to mass of the solvent. And now we are writing that molality is equal to number of moles, solute number of moles. Already we have taken 1 liter, so moles is 2.05. So number of moles of solute upon mass of the solvent in grams, so divide by 1000. So 1000 will come in numerator, and if we simplify, definitely this value will be greater than 2.05. So if we solve, we are getting 2.285. So what I am saying that, don't forget the definition of molality. In denominator, it is not mass of the solution, it is mass of the solvent. And while solving, apply the concept that all concentration terms are intensive variables. So there are many questions based on this. You are able to solve those questions. And one more thing, like they are asking some concentration term, which concentration term is temperature dependent and which concentration term is independent. So we know that like mole fraction, molality, these are temperature independent, while capital M molarity, it is temperature dependent. Density, it is temperature dependent. So in a concentration term, if volume is coming, so we know that when we change the temperature, volume of a substance will change. So those concentration terms in which volume is coming is dependent on temperature, and those in which mass is coming or moles is coming only, volume is not coming, then we can say that those are independent of temperature. Like molality and mole fractions are independent of temperature. Okay. I have seen many questions of Zeldal method, right? Each and every paper, almost each and every paper has a question of Zeldal method, and very simple question it is coming. So let me discuss. There are two methods to estimate the amount or percentage of nitrogen in an organic compound. One is known as Dumas method and the other is known as Zeldal method. So we are discussing about Zeldal method. So this is related to estimation of nitrogen in an organic compound. The compound containing nitrogen is heated with concentrated H2SO4. Nitrogen in the compound is converted into ammonium sulfate. The resulting acid mixture is then heated with excess of NaOH. The liberating ammonia gas is absorbed in excess of standard solution of H2SO4. The amount of ammonia produced is determined by estimation of the amount of sulfuric acid consumed in the reaction. So the point is that whatever the nitrogen present in the compound, that nitrogen is converted into ammonium sulfate by reacting with concentrated sulfuric acid. And this ammonium sulfate is a salt of weak base and strong acid. When this ammonium sulfate is treated with a strong base like NaOH, strong base will displace weak base. So ammonia gas will liberate. And that ammonia gas is absorbed in standard sulfuric acid solution whose concentration is known. So sometimes they will give directly that what amount of sulfuric acid is consumed. Sometimes indirect, they will give excess amount of, because we are absorbing this ammonia in excess amount of H2SO4 solution. So we have to do back titration. We have to treat the sulfuric acid left in the solution by some standard NaOH solution. So these are the concept for Zaldal method. I am taking one example to explain you. So let me read this question and then we'll discuss the concept. So in Zaldal method for estimation of nitrogen in organic compound, they have given the mass of organic compound is 18.6 gram, is heated with excess of concentrated sulfuric acid and then excess of NaOH. The ammonia gas is absorbed in 200 ml of 2 molar H2SO4 solution. The excess of acid, they are talking about this sulfuric acid, required is 300 ml of 2 molar NaOH for back titration. Find the percentage of nitrogen in organic compound. So here, whatever the ammonia liberated, it is absorbed in sulfuric acid. So this sulfuric acid is reacting with two base. One is ammonia and other is the left amount of sulfuric acid is again back titrated with NaOH. So these are the two reactions. We have balanced these reactions. So from this reaction, I can write that the number of moles of sulfuric acid consumed is half times the number of moles of ammonia. So I can write that the total number of moles of sulfuric acid will be total number of moles of sulfuric acid into 2, because I am writing the number of moles of ammonia. From the first reaction, number of moles of ammonia is 2 times the number of moles of sulfuric acid, and number of moles of NaOH is also 2 times. So if I add this number of moles of sulfuric acid, I am getting this relation. Now from here, since they have given molarity and volume in ml, I will get that what is the millimoles of sulfuric acid. So 2 into 200 into 2. So this is 800 millimoles. Millimoles of ammonia I have to calculate. Millimoles of NaOH they have given 300 into molarity is 2. So 600. So if I simplify, I am getting 200 millimoles or 0.2 moles of ammonia. The number of moles of ammonia is equal to the number of moles of nitrogen. In 1 mole of ammonia, 1 mole of nitrogen is there. And this nitrogen is coming from organic compound. So this is the number of moles of nitrogen in organic compound. From there, we can calculate that what is the mass of nitrogen in organic compound. So mass is 0.2 into 14 divided by total mass of organic compound into 100. By this we can calculate. So each and every paper, almost each and every paper has this question, Zaldal method. So be careful about that. Let us move forward. Carius method in 2022, in few papers they are asking question about Carius method. So this Carius method is used for estimation of halogen, it is used for estimation of sulfur, and it is used for estimation of phosphorus. And these are in organic chemistry, right? Quantitative estimation of elements in organic compounds. So there it will come, but it's easy to discuss in mole concept. That's why I'm doing it. So for estimation of halogen, very simple concept, this Carius method, there is a tube called Carius tube in which these processes are carried out. So I'm reading for estimation of halogen. A known mass of organic compound is heated with fuming nitric acid in the presence of silver nitrate in a Carius tube. So this nitric acid is an oxidizing agent. So if organic compound containing carbon, nitric acid will convert into carbon dioxide, hydrogen, H2O. So the remaining halide present in halogen present, since it is treated with silver nitrate, it is converted into silver halide, AgX. And that AgX is insoluble in water. So what we do that, will carbon and hydrogen in compound is oxidized to CO2 and H2, and the halogen present forms silver halide. It is filtered and washed and weighed. So by measuring the mass of silver halide, we can find out the number of moles of silver halide, and the number of moles of silver halide is equal to the number of moles of halogen. From the number of moles of halogen, we can calculate mass of halogen. Mass of halogen upon mass of organic compound into 100 will give you the mass percentage of halogen in organic compound. This same method. So here there is an example. I'm not going through this example. Just I'm telling that 2022 they have asked question about Carius method, which is very simple. Same type of question they can ask regarding estimation of sulfur. So the sulfur present in organic compound, again it is treated with HNO3, fuming HNO3, or it can be used another oxidizing agent, sodium peroxide. So these oxidizing agent will convert this sulfur into sulfuric acid, and then this resultant solution is treated with excess amount of barium chloride. So barium chloride, barium 2 plus ion and sulfate ion will combine to form barium sulfate, and we will measure by this precipitate is washed and dried, and the mass of barium sulfate is measured. So from mass of barium sulfate, we can calculate what is the moles of barium sulfate. And the number of moles of barium sulfate, the number of moles of sulfur and barium sulfate is equal. So from there, we'll calculate the mass of sulfur upon mass of organic compound into 100 will give you the percentage of sulfur in organic compound. And this is the most difficult one, estimation of phosphorus, right? So what we do here again, the phosphorus present in organic compound is heated with fuming nitric acid, which is an oxidizing agent. So the phosphorus present in that compound is converted into phosphoric acid, and then this phosphoric acid can be further treated by two methods in order to determine the amount of phosphorus in organic compound. So once we know that the phosphorus in organic compound is converted into phosphoric acid, now in one method is phosphoric acid is treated with HNO3 and ammonium molybdate. Here molybdenum is present in +6 oxidation state, you can calculate, right? And these reactions are there, so you should know that what is the formula of ammonium molybdate, because they can ask a question that what is the oxidation state of molybdenum in ammonium molybdate. So by this reaction, the phosphorus present here will form a yellow precipitate. The name of this compound is ammonium phosphomolybdate, and this is a precipitate. So definitely this is its molar mass 1877. So when we do this reaction, this precipitate will filtered, then it is washed and dried, and from there we can calculate the mass. So mass of this precipitate upon its molar mass 1877 will give you the number of moles of this precipitate. And in the balance in the formula of this, the number of moles is equal to number of moles of phosphorus. So we know the moles of phosphorus into atomic mass. So mass of phosphorus upon mass of organic compound into 100 will give. So this is one method. In another method 2, we treat this phosphoric acid by magnesia mixture. Magnesia mixture is a mixture of MgCl2 and NH4Cl. So this phosphorus is converted into white precipitate, magnesium ammonium phosphate, and this HCl gas will be liberated. Now on heating this magnesium ammonium phosphate, so this is the reaction, magnesium ammonium phosphate is subjected to strong heating. So this ammonia gas and water will remove in the form of water vapor. This residue is left. So we know that when from two molecules of phosphoric acid, if we remove a water molecule, then pyrophosphoric. So it is a salt of pyrophosphoric acid, pyrophosphate, magnesium pyrophosphate, Mg2P2O7. Its molar mass is 222. So they will give the mass of this Mg2P2O7, magnesium pyrophosphate. And from there, we know that number of moles is 2 times the number of moles of this compound. So from there, we know phosphorus moles, we multiply by atomic mass, we know the mass of phosphorus upon mass of organic compound into 100 will give the mass percent of phosphorus in organic compound. This is a question regarding volume strength of H2O2 solution. So there are two spatial concentration term. One is H2O2 and other is oleum. I'm not discussing about oleum because about oleum it is not mentioned anywhere in NCERT, and in any year they have not any question about that oleum. So we are not discussing about oleum, but we are discussing about volume strength of H2O2. And why I am discussing this? Because there is some confusion. I want to clear that confusion, right? We know that 20 years back, the STP condition was pressure is 1 atm and temperature is 273 Kelvin. So according to old STP condition, if I find out or calculate, if I calculate the volume of 1 mole of a gas by using PV is equal to nRT. I'm getting that volume for 1 mole of gas at old STP condition is 22.4. So this change has happened 20 years back. So now according to new STP, standard pressure is not 1 atm, it is 1 bar. And if pressure is 1 bar and if we calculate the volume, it is 22.7 at new STP condition. So because of this old and new STP condition, this confusion is coming. So this is a question of JEE Mains 2021, or this type of question is also asked in JEE Advanced. But they have clearly mentioned the condition. What is the condition? That the volume strength of 8.9 molar H2O2 solution calculated at 273 Kelvin and 1 atm. So they have given, do not have to confuse when they will give at what pressure and temperature we have to calculate, right? But in your NCERT, they have also given this example. They are asking volume strength and they have used this 22.7 also, right? If nothing is mentioned, you can solve this question by old STP as well as new STP. They have to take both ranges. But if nothing is, if it is mentioned that at under what condition, then there is no confusion. But if nothing is mentioned, then you can solve by old method, you can solve by new method. They have to give the range. So do not hesitate while solving if they have not mentioned it is old or new. But JEE Mains and Advanced are not doing this mistake, because they are now mentioning, they are not saying STP, they are giving the condition of temperature and pressure. So let us discuss the concept used, because this question is simple only. So when we are discussing about the formula that volume strength is molarity divided by 11.2, or molarity is volume strength divided by 11.2, or molarity according to new is volume strength divided by 11.5. Concept is simple. In aqueous medium, H2O2 is unstable. So since it is unstable, it will decompose to H2O and half of O2. So in this balance reaction, I can say that the number of moles of oxygen produced is equal to half times the number of moles of H2O2 decomposed. When we define volume strength, what is volume strength? It is the volume of oxygen gas obtained in ml by decomposition of all the H2O2 present in 1 ml of H2O2 solution at STP, right? It is not necessary that volume in ml. If we take volume of H2O2 solution in liter, this is the volume in liter. Whatever the unit of volume we are taking for solution, the same unit will take for oxygen gas. So we can say for unit volume of H2O2 solution, what volume of oxygen gas is liberated, that is the meaning of volume strength, right? And it is liberated at under certain condition of temperature and pressure. So the concept is that if I solve this question, I have calculated that what is the number of moles of oxygen. Number of moles of oxygen is equal to number of moles of H2O2 divided by 2. Now for gas, number of moles can be calculated. Volume, if it is 1 atm and 273, then I will divide 22.4. So volume in liter divided by 22.4 is number of moles of oxygen. From here I can calculate number of moles of H2O2 is volume of oxygen divided by 11.2. So now molarity of H2O2 is number of moles of H2O2, which I have calculated volume of oxygen divided by 11.2, or this volume of oxygen is volume strength, because I am saying that from 1 liter of solution, how many liters of oxygen is liberated at STP condition. So because of that, we are using this formula that according to old convention, molarity is equal to volume strength divided by 11.2. And now if they are saying that you have to calculate at 1 bar and 273 Kelvin, then in place of 11.2, you can write by the same method, you can write that it will be 11.35, because at 1 atm and at 1 bar and 273 Kelvin, volume of 1 mole of ideal gas is 22.7 liter. Okay, there are certain things which I want to discuss here. One more thing is there, because this is molarity and volume strength. They can also discuss the strength of H2O2 solution. So when we are discussing the strength of H2O2 solution, like here, we know that molarity is equal to number of moles of H2O2. Number of moles of H2O2 is mass of H2O2 divided by molar mass. Molar mass of H2O2 is 34. So I am writing the definition. volume of H2O2 solution in ml divided by 1000. This 1000 is in the numerator. So here it is mass of H2O2. I am discussing about this. This is mass of H2O2 in gram. Mass of H2O2 is solute and water is solvent. And this is the volume of H2O2 solution in ml. So mass of H2O2 solution in gram upon volume of H2O2 solution in ml is known as strength in gram per ml. So unit is gram per ml, but it is not density, because in density it is mass of solution. When we are discussing strength, it is mass of the solute upon volume of the solution. So that we can simplify here, because if I simplify, 34 divided by 1000 is 0.034. So we can write that 0.034 into molarity of H2O2 is equal to strength of H2O2 solution in gram per ml. And we know that molarity, if I have to write molarity of H2O2 and they have given volume strength, if according to old convention, I can write that is equal to volume strength divided by 11.2. According to new sign convention, if I have to write molarity, I have to use H2O2 volume strength divided by 11.35. If they have not mentioned anything, you can use this also, you can use this also. Or if they have mentioned the condition, then according to condition, you can find out. And same way, you can find out that what is the strength of H2O2 solution in gram per liter. That is mass of H2O2 present per liter of the solution. So if I have to write, then volume by 1000, this is per liter of the solution. So only 34 will be left. So molarity into 34, molarity of H2O2 solution into 34 is equal to strength of H2O2 solution in gram per liter. And I have seen few questions based on ppm. You know the definition of ppm. I want to just give you a suggestion, because ppm, when we are writing for very dilute solution, right? So ppm, mass of solute in gram divided by mass of solution. But since the solution is very dilute, we can say that mass of solution is approximately equals to mass of solvent. So they will give the mass of solute and solvent both, but if you add solute is negligible. So practically you can put here mass of solvent in gram into 10 to the power 6. So we're going to discuss about ppm in hardness of water and hydrogen and its compound also. We are going to discuss this in ionic equilibrium also, where ppm is used for partial pressure of gas upon total pressure into 10 to the power 6. I have neglected or removed those things which are very interesting but not useful for our mains preparation. So keeping that in mind, we have discussed mole concept. Now, during evening time, near about 6 p.m., I am going to discuss or share the video of redox, which is very important for us. So if you are liking our video, you should share between your friends so that most of the students get benefited from this series, which is free for all the students. Thank you.